In the previous class, we have discussed about the control mechanism for the particulate matter. Today, we will discuss about the control mechanism for the gaseous form of the pollutant. So as we have discussed in the previous class, emission from the industry, emission from the power plants, emission from the transportations, these all pollutant consist of mainly two types. First is the particulate matter and another can be the gaseous pollutant. The examples of gaseous pollutants may be the oxides of carbon, oxides of sulfur, oxides of nitrogen, volatile organic carbon, ozone, and there may be more. So as we have discussed in the previous class, basically there are two types of pollutant. One is the particulate matter and another is the gaseous, in the gaseous form. And we have to apply the mechanism only to control these two types of pollutant. So we have discussed in the previous class about the control mechanism of particulate emission. Today we will discuss about the gaseous emission control. So as we have discussed in the previous class, as far as the control mechanism is concerned, we can control the pollutant at the source itself by modifying the source. And also we can control the air pollution by using some equipments. We have discussed 4 different processes by which the air pollution can be controlled at the source itself. So it is the fuel substitution, process modification, modification of existing equipment, maintenance of equipment. This is also valid for the gaseous pollutant. We have discussed it for the particulate matter, but it is equally viable for the gaseous pollutant. Let us suppose if some gas is causing, if some fuel is causing a lot of problem, let us suppose some fuel has sulfur in it. Certainly we have to remove it. Sulfur will come into the atmosphere. It can make sulfur dioxide. So if anyhow we will make some modification in the fuel, or if we will able to replace the fuel, then also we can control the emission of gaseous pollutant into the atmosphere. Basically, as far as gaseous pollutant is concerned, there are 4 mechanisms or there are 4 processes by which it can be controlled. One is adsorption, absorption, oxidation and reduction, and another is combustion. Combustion is also known as incineration. So first of all, we will discuss about adsorption. So adsorption involves the interaction between gaseous contaminants and the surface of a solid adsorbent. So whenever a pollutant will adsorbed on a surface, that means it will only get attached on the upper surface. It will not go, it will not penetrate inside it. That's why it is the interaction only on the surface. Adsorption will always take place on the surface, not beneath the surface. There are basically 2 types of adsorption. There are 2 mechanisms. One is the physical method and another is the chemical method. Physical form of adsorption, examples are pellets in thick bed we can use. We can use fibers pressed onto a flat surface. These are the way by which the adsorbent can be placed in the chamber so that the gaseous pollutant can adsorb on the surface. Physical adsorption, basically it is used for organic pollutant. Chemical adsorption is generally used for acids, acid gas. For example, the hydrogen sulfide, hydrogen chloride, hydrogen fluoride, these type of gaseous acid. To control these type of gaseous acid, we generally use the chemical adsorption. Most organic compounds with molecular weight greater than 50 and less than 200 are collected with high efficiency. So you have to see the molecular weight of the organic compound. If the molecular weight is too low, let us suppose the molecular weight is 30, 20, it is not possible to adsorb it in by any adsorbent. So basically, if the molecular weight of the organic compound is between 50 to 200, only then the efficiency of adsorption will be high. This is a simple diagram which is showing the process of adsorption, and the adsorbent which is used here, it is the activated carbon. So activated carbon has a great tendency to adsorb the pollutant, and it is most commonly used adsorbent. The other examples are alumina, bauxite, silica gel. These are also used, but activated carbon, generally this is used. Activated carbon is also used to remove contaminant from the water sources. If there is pollution in water also, this activated carbon is strongly used to adsorb the contaminant of the water. We will discuss it in the water pollution class, but activated carbon is a very strong and very easily available economical adsorbent. So what happens? First of all, the raw gas, or you can say that the polluted gas, enter into the system. The velocity of the flow, it may be increased by using some fan. So when it will pass through this chamber, there is a facility which is provided and of the adsorbent, and the adsorbent is activated carbon. Certainly when it will pass through it, some of the gaseous molecules, it will get adsorbed on the surface, and rest of the fresh air or clean air, it will get out from this chamber. Here it is also shown a burner by which by combustion also, incineration also, we can reduce some harmful gases into some low impact gaseous form. So by incineration also, the gas is coming into this side from raw gas, it coming into this side, and incineration also it is becoming clean, isn't it? So basically, as far as the adsorbent is concerned, it is only this chamber. So simply the gas will come, the polluted gas will come, it will enter into the chamber. There will be facility of activated carbon in the chamber. When the pollutant will pass through this activated carbon, some of the pollutant will get adsorbed on the surface, and rest of the clean gas we can take out from another way, from this portion, isn't it? So basically, this activated carbon adsorbs organic gases and vapors with and without the presence of water. Gas adsorption practice normally focuses on the removal of volatile organic compounds, isn't it? So basically, it is for volatile organic compound, and the adsorbent which is used here, it is the activated carbon, isn't it? There are few points which we have to remember, or we have to keep into mind as far as the adsorption process is concerned. So as we have discussed, adsorption will be of the efficiency of the adsorption process will be high if the molecular weight of the organic compound, it will be between 50 and 200. Both physical and chemical adsorption system are most efficient at high contaminant concentration. So if the concentration of contaminant is high, only then the efficiency will take place. Efficiency will be good. Or both physical and chemical adsorption is possible. Essentially, all adsorption processes work best when the temperature is low. Only up to 3 organic compounds can be adsorbed simultaneously. So this is one of the constraints. If your gaseous pollutant consists of more than 3 organic compounds, then the efficiency of removal of the contaminant, it will get reduced. So the process is not suitable if we have more than 3 gaseous pollutant or 3 organic pollutants. Deposition of particulate matter may reduce efficiency of adsorption because the raw gas or the pollutant gas which is coming, it will also have some particulate matters, isn't it? This facility we have developed for gaseous pollutant, but the pollutant will, the gaseous pollutant, it will also consist some particulate matter. So certainly when the particulate matter will come into the system, some of the particulate matter may get deposited on the surface. So it can make this, the process choked, isn't it? That's why deposition of particulate matter may reduce efficiency of adsorption. Another process is absorption. Absorption. So in absorption process, what happens in adsorption? Only the upper surface of the adsorbent, it attracts the pollutant and get it deposited on the surface. But in case of absorption, the gaseous pollutant can get absorbed beneath the surface of the absorption body also. So gaseous contaminant soluble in aqueous liquid can be removed by absorbers. Effective for acid gas compounds. So if the pollutant is acid gas, for example, SO2, sulfur dioxide, if it is HCl, then for these type of compound, absorption is basically important. And it is generally done with the help of aqueous liquids. So absorption process is important only for gaseous contaminant soluble in aqueous liquid. It is effective for water soluble organic compounds, for example, alcohol, aldehydes, etc. Contaminant gas or vapor is absorbed from the gas stream as it comes into contact with the liquid. Rate of pollutant capture increases as the contact between the liquid and the pollutant will increase, isn't it? So if the surface area between the exposed area, between the pollutant and the absorbers, if it will increase, certainly the efficiency will get increased. This is a layout for the process of absorption. So waste air will, or the pollutant air will enter from this side. There will be a absorption column. Aqueous liquid can be used into this column. And when it will pass through it, the gaseous pollutant will get adsorbed and it can get out from this plant. So the remaining gases, it can come into the desorption column, isn't it? And from here, it can also come out. So all absorption processes operate best when gas and liquid temperature are low. So both for absorption and adsorption process, the temperature should be low. Now we will talk about combustion. It is also known as incineration. It is basically applied when the pollutants are organic gases or vapors. There are two ways by which combustion can be done. One is the thermal method. That means simply you have to heat it, you have to give fuel, isn't it? By use of fuel, you have to heat it, or by electricity, you have to heat it anyhow. Or you can use some chemical or catalyst. So thermal combustion is possible and catalytic combustion is possible. The end product of the combustion is CO2 and H2. That means it will reduce the contaminant into less harmful products. There is one constraint with the combustion. When you will burn some of the pollutant, or when you will incinerate some of the pollutant, there may be chances that dioxin will get released into the atmosphere, isn't it? This is one of the constraints. This is a simple facility for incineration, isn't it? So you can see this is the combustion chamber and pollutant is entering. So this, and after combustion, with the help of fan, why fan is has been placed here, so that the velocity of the gas, the velocity of the clean gas, it can get increased and it can go into the atmosphere, isn't it? So thermal oxidizer or thermal incinerator. So oxidizer, thermal, you call it thermal oxidizer, or you can call it thermal incinerators, are combustion devices that control VOC, CO, and volatile HAP emission by combusting them to carbon dioxide and water. Another process by which the gaseous pollutant can be controlled, that is the oxidation system. So these oxidizers are basically used for organic compounds. There may be three categories of oxidizer: thermal, catalytic, or flares, isn't it? Not very dependent on the actual temperature of the process. So we have seen in adsorption process and in absorption process, the temperature should be low, but here it is not compulsory. Flares are used primarily to treat emergency vent gases in synthetic organic chemical plants and petroleum refineries. So you must have seen this type of figure. This is the flare. This is known as flare or flaring. So if the gaseous pollutant are coming out and you want to burn it immediately, then you have to take the help of these flares. So basically these flares is a VOC combustion control process in which the VOC are piped to a remote, usually elevated location. So it is at the elevated location, isn't it? It is at the elevated location and burned in an open flame in the open air using a specially designed burner tip, isn't it? So auxiliary fuel and steam or air to promote mixing for nearly complete VOC destruction, isn't it? So it is generally used in refinery units, because in refinery units, the volatile organic carbon, it has a good percentage. So you have to remove it, isn't it? Or anyhow, it will get removed. So it should, the hydrocarbon as such, it should not go into the atmosphere. That's why this flaring technique is used to decompose it or to convert it into carbon dioxide and water molecules. Another process is the reduction system. So simply, what is oxidation? Oxidation is when you provide oxygen to the system, then it is oxidation. And what is reduction? When you remove it from the system, isn't it? So basically, this reduction system is for NOx compound emitted from combustion processes. A chemically reduced form of nitrogen is injected into the gas stream to react with the oxidized nitrogen compound, namely NO and NO2. The end product, what you will get as, after reduction and oxidation, you will get N2. So reduction process is generally used for NOx compound, and as reducer, you can use ammonia and urea. One of the process to control the gaseous emission is the condensation. For recovery of organic compounds present at moderate to high concentration in industrial process effluent gas streams, this process of condensation is used, isn't it? Water-based direct and indirect condensation. These are the three types of condensers which is used. One is the water-based direct and indirect condenser, and there is refrigeration condenser, and there is the cryogenic condensers. So you see, it has been divided, these three has been divided on the basis of the temperature or the atmosphere in which it will function. So water-based condenser will work from 40 degree Fahrenheit to 80 degree Fahrenheit. Refrigeration condensers, it will function at minus 50 degree Fahrenheit to minus 150 degree Fahrenheit. And cryogenic condensers, it will function at minus 100 degree Fahrenheit to minus 320 degree Fahrenheit. So condensation process, simply it use the condensation process, isn't it? You have molecule, certainly if you have molecule and you want to convert it into liquid form, so certainly condensation process is used. Similarly is the, since if you want to condense some of the gas, you have to lower the temperature, isn't it? That's why these temperatures are very low, and for process you are using these type of condensers. So what is the summary? Basically, we have seen that to control the gaseous pollutant, we use these type of control techniques, isn't it? Biological treatment is also one of the part, we have not discussed it. So one is absorption and there is adsorption. We have discussed about the oxidation, we have discussed about the reduction, and we have also discussed about the condensation. So for which type of pollutant it is valid, you can see from here. For absorption, acid, gas, and organic compounds can be easily treated, easily removed. From adsorption, acidic gases and organic compounds, it can be reduced. From biological treatment, organic compounds can be reduced. Organic pollutant can be purified. From oxidation, for oxidation, organic compounds, it can reduce the organic compounds. Reduction process, it is helpful for NO and NO2, and condition, it is for condensation, it is organic compounds. So this is the applicability. So if the pollutant is in this nature, whether it is acidic, gas or organic compounds, these processes are generally used. So out of all these processes, you are saying that for the nitrogen compound, nitrogen oxides, reduction process is more suitable. Reduction process is more suitable. As far as acid, gas, and organic compounds are concerned, we can use absorption process, adsorption process. It depends upon the temperature, it depends upon the type of acid which we are using. Some acids can be easily adsorbed, some acids can be easily absorbed. So it depends upon the acidic nature of the gas and the organic nature of the gas. We have to use the process adsorption and absorption. So for example, we have talked about that the molecular weight of some organic compound should be in the range of this and this, then it will be used, isn't it? So there are some constraints. We are not discussing about the constraint, but in a very simple manner, it has been presented and it has been shown that for acid, gas, and organic compounds, these processes can be used. Condensation process, it is only used for organic compounds. Biological treatment, from biological treatment, only organic compounds can be treated. So if you want to treat the acid, gas, and organic compounds, certainly the absorption process and adsorption process are the two methods, if simultaneously both are present. So what should be the concentration? Concentration range has been shown here. So and also the range of the temperature has been shown here. Applicable for control of multiple contaminants. So we can see here that these all processes can handle multiple contaminants, isn't it? So if the organic compound or organic pollutant is more than 2 or 3 types or 4 types, it can handle. But we have seen also the constraint that some process, adsorption process, cannot handle more than 3, isn't it? Applicable for control of gas streams with particulate matter. So it is very important to see that if we have to reduce, if we have to treat the gaseous pollutant, then whether the pollutant, whether the particulate matter which is coming with the process, it will increase the efficiency, it will decrease the efficiency, or we have not to use, or we have not to allow the particulate matter to get flowed with the gaseous pollutant. So if the gaseous pollutant, you can see here, so if the pollutant, if the gaseous pollutant is mixed with particulate matter, both are coming into the system, into the purifying unit. So only 2 processes which will be allow it to do so, that is the absorption process and there is the reduction process. Otherwise, for all other, for adsorption, for biological treatment, for oxidation, for condensation, the pre-treatment is required. What is the meaning of pre-treatment here? It means that when the gaseous pollutant, when the raw pollutant is coming into the system, you have to separate the particulate matter from the organic pollutant, or you have to separate the particulate matter from the gaseous pollutant, and you have to allow only the gaseous pollutant to enter into the system, isn't it? That is the meaning of pre-treatment. That means you have not to allow the gaseous pollutant, you have not to allow the particulate matter to enter into the system. Only the gaseous pollutant will go into the system, then only the adsorption process will be effective. If anyhow the particulate matter will enter into the system with the gaseous pollutant, then it will get deposited into the surface and the adsorption process will be hampered. That's why pre-treatment is important, isn't it? So as we have seen into this figure, so this uncleaned gas is coming, and this is the process of adsorption. So this raw gas will contain both the both type of pollutant. It will contain the particulate matter also, it will contain the gaseous pollutant also. So we cannot allow the particulate matter, to enter into the system. That's why the pre-treatment is important. After the pre-treatment only, when the particulate matter will get filtered, only the gaseous pollutant will be allowed to come into this chamber. Okay, only in that case it is valid. If both will come, then the particulate matter, it will get deposited into the system and it will create some problem. Isn't it? Okay. So today we have discussed about the gaseous pollutant control. Isn't it? How we can control the gaseous pollutant, which is coming from some industry, which is coming from some transportation, isn't it? Okay. So there are many type of pumping which is going on for the air pollution control, and I'm showing you few of the pumping here. So one is from the Breath Life. It is a global pumping, and you can see what it is giving the message to the society. So basically, the air pollutant, they are saying that the air pollutant is a invisible killer, isn't it? And you see that the percentage of death which is caused by different type of diseases which is mentioned here, and you see all these are related to lungs, isn't it? So basically, why it is infecting the lungs? Because the air pollutant is coming, and first of all, when we breathe, it will go into the lungs. So 29% of the death is only causing due to lung cancer. 43% of the death is causing due to lung diseases, isn't it? 24% of the death is causing by the heart diseases. 24% of death is causing from the stroke. And as per the estimate of WHO, 7 million people die prematurely every year due to outdoor and household air pollution. Another pumping you can see, air pollution is not a joke. Air pollution will make you choke. I have taken it from sloganshub.com, but this is a very nice message they are trying to give. We take it very easily we take. We never care about the air pollution. We never try to stop somebody or some industry which is causing it on the personal basis. Government is also trying. Government is trying to do, but it should be taken on the individual basis also. Okay, there is a small video which is prepared by WHO, and the information is about the air pollution.
Young and old. It slips unnoticed past your defenses and assaults your lungs, heart, and brain. Its deadliest weapons are invisible, poisonous particles that can be as small as a molecule. With every breath, they break through your lungs' protective barriers. There, they trigger inflammation as your system tries desperately to fight back. But these tiny intruders penetrate those defenses, lodging toxic compounds even deeper, sowing the seeds of cancer. They slide straight into your bloodstream, sabotaging your entire body. They inflame and constrict your blood vessels, increasing blood pressure until, one day, causing a stroke. The particle prowlers dislodge fatty plaque that may have built up from your diet. They leave clots that can be deadly blockers of blood flow to your heart or brain. With each new case of heart attack, stroke, lung disease, or cancer, air pollution adds another life to its hit list. Let's stop this invisible killer.
Okay, so air pollution, this is the comping video which is prepared by WHO, and okay, with this, thank you very much for listening.